Good evening, guys. This is Yushva Nagendra Reddy, pursuing BTech second year in the branch of PCE. I'm here to represent my seminar topic on the flip-flops in the subject switching theory and logic design. Flip-flops. What is meant by flip-flops? A flip-flop is an electronic circuit. We have so many electronic circuits in the electronic device. Same like as a flip-flop is an electronic circuit, but it stores only one value, either it is 0 or 1. In the electronic devices, flip-flop acts as a tiny memory that remembers something until it is changed. It is just like acts as a switch in the electronic device. If the flip-flop is on, means a switch, it acts as a like switch no, because if it is on, it stores the value 1, and if it is off, it stores the value 0. It will keep that value until signal is changed. What the previous value is taken by the flip-flop, it will be stored in the flip-flop until a signal is changed. Types of flip-flops. Basically, we have four types of flip-flops in the switching theory and logic design. In the two one, first one is RS flip-flop, or else it also call it as SR flip-flop. And second one is D flip-flop, and next KJ flip-flop or JK flip-flop, and another one is T flip-flop. Coming to the SR flip-flop or RS flip-flop. The figure shows This figure shows a circuit diagram of the SR flip-flop. In the SR flip-flop, we have two AND gates and two NOR gates. One the output of the one OR gate is connected to the one terminal of the another NOR gate, and similarly same like as that output is connected to the one terminal of the another NOR gate. And here same common common connection for the clock pulse to the two AND gates, and another two terminals is inputs for the circuit, that is called R and S. Here clock pulse, if the clock pulse is 1, it can perform the some function in the logics in the circuit. If it is 0, we cannot produce any kind of output in the flip flop. And this is the characteristic table of the SR flip flop. The characteristic table of SR flip flop tells how the next output. It means for the circuit we are giving the inputs as S and R. For this we are giving the S and R inputs. We get the output as Qn. In the table we can see that here 0 0 0, S0 R0, Q0, S0 R0, and Q1. Similarly like this, we have first both inputs are 0, one possible. Both inputs are 0, and we get the output 0 if it is one possible. And here similarly same both inputs is 0, and we have another possible output as 1 on output 1. Similarly here three possibles there. 3 means 8. We are getting the 8 possible things possible for the SR uh, SR SR flip flop. By depending on this, we can get the next we can get the next output Q1 to Qn plus 1. Qn is the previous, Qn plus 1 is the next. Present is Qn, next is Qn plus 1. By this characteristics table, we can get the next output of the SR flip flop. And characteristic equation and excitation table of the SR flip flop. Here we have two figures in this slide. First figure is how the characteristic equation is coming from the four variable K map, and the next one is excitation table. Let us see first the behavior of the this characteristic equation by taking the, and we know the when the output means next state output is 1. By taking consider into these outputs, we can build a 4 variable k map like this as shown in the figure. And by grouping these elements, we get the characteristic equation is s plus r bar qn, and figure 2 shows the excitation table of the SR flip flop. Here qn plus 1, qn qn plus 1, and inputs is s and r. What is meant by excitation table means we are getting the present input, we are getting the inputs from the next and from the present and past outputs. Excitation table SR flip flop shows the inputs. What are the inputs? What are the inputs are required to change the flip flop from present state to next state? Like this, we get the inputs S and R. This is characteristic excitation table. And second, next one is D flip flop. A D flip flop, or it can call as data or delay flip flop, is a memory device that stores the 1-bit data. And we know that flip flop is an electronic device. It already we learned in the introduction about the flip flop. And D flip flop is a memory device that stores a 1 bit, either it is 0 or 1. Next, okay. Whatever the value you given to the input D, the flip flop stores the same value at the output to Q on the clock edge. What it means, whatever the input is given to the D, we can get the same value at the output to Q on the clock edge. Here D flip flop means just rearrangement or connect the, we can get the D flip flop from the SR flip flop. If the connect the both S and R flip flops and connect a NAND NOT gate between the between the inputs of the R and S, we can get the D flip flop. And then and the gates doesn't change. It remains constant, and it is a characteristic table. Here is the characteristic table of the D flip flop, and D flip flop means it is only one. It means we can get 0 or 1. Only two possibilities for given to the input for the D flip flop. And characteristic equation means we are getting the next state. We are getting the next state means by consider based upon the input and present state and in input and present state. We have two means four possible conditions. By taking this into, you can get the qn plus 1. And next, another one is characteristic equation excitation table of D flip flop. Similar to the SR flip flop, we are getting the excitation table and characteristic equation by using four variable k map. By using four variable k map, when qn plus when we observe the previous table in the characteristic table, when the qn plus 1 state is on, by taking this consider that one and fill the four variable k map and group it, we can get the excitation characteristic equation as Q is equal to D, and figure 2 shows the excitation table of D flip flop. And we know the deep excitation table means we are getting the present input from the present state and next state. From the we get the present required input for the D flip flop. And third one is JK flip flop. JK flip flop means we are connecting the outputs to the extra input to the NAND gate. Similarly, both NAND gates is connected to the both NAND bits connected from the output. Here the JK flip flop is, and it can be called as a universal flip flop. A JK flip flop is a memory unit that changes its outputs based upon the J and K when the clock pulses arise. And characteristic table, similar to the behavior of the characteristic tables is same for every flip flop. Here it is a characteristic table of JK flip flop. JK takes it is very similar to the SR flip flop. And characteristic equation and excitation table. And here in the next state, the taking consider the on state for the present next state, and fill the uh, four variable k map and values group the values. We can get the characteristic equation of the jk flip flop, that is j q bar plus k bar q. Characteristic equation of jk flip flop shows the next state qn plus 1 in terms of present state qn and qn inputs j and k. And similarly jk flip flop, and for excitation table for the jk flip flop is the excitation table of jk flip flop shows required values of j and k that will be produced desired change from present state to next state, similar to previous one. And last one is t flip flop. T means toggle. Toggle means when the it is very simple. When the output is 1, let us example now the present output is 1, and it will and will do and it what is the converse of the output? Q means q bar. If it is 1, next output is 1. If now present output is 0 and next output is compulsory, it will be 1. T flip flop means it's change the output 0 to 1 or 1 to 0. When t is equal to 1, it retains the previous state value t is equal to 0 on the clock edge. And characteristic table of a t flip flop shows the next state and obtained from the previous and the next state qn for the different inputs of q. And here it is the characteristic equation excitation table of the T flip flop. Figure 1 shows the characteristic equation, and next one is excitation table. Here we observe the if you observe the excitation table of the T flip flop, the present state is 0. The present state is 0. Next state is 1, 1, 1, 1, 0. When toggle required input toggle 1 means it will be it only once means. And thank you.